Hey guys, Mr. T here. This is another video. This one is on problem solving or problems involving bearings. And I'm going to try to show it to you using a protractor, because that's what you'll be doing in this topic, because you will not be using sine, cos and tan. You won't be using trigonometry. You need to use a protractor. And yeah, you don't have a calculator for this either. So you need to be able to see how a protractor is used. I'm going to do my best to show that on this iPad. Using a ruler on it as well. So bear with me if it takes me a long time to line things up. That's because I'm trying to line plastic things up on a glass screen, so it's very, very slippery. So, what's the idea of bearings? Bearings tell you the direction of one object in relation to another, or points really. You're going to be talking mostly about objects being points in space. The direction is in comparison to the direction of true north. So the bearing is a number that you'll get, and it's a number that's based on how far around it is from the direction of true north, which will most commonly be directly up on your page. So the bearing itself is a number, and it's given as 3 digits, and the units for it are degrees. So the little circle in superscript or email. True north is considered 000 degrees. So you'll notice that we say we give bearings in 3 digits. So if we're saying 0 is true north, you'll write it as 000 degrees. And the bearing increases in a clockwise direction. So if your true north was straight up and down like this, and that's 000 degrees, that number would increase as you go around. So here would be 180 degrees, and then you keep going in a clockwise direction. If you reach the other, reach back up to true north, you would have gone a full 360 degrees. Okay, so on the right, that would be 090 degrees. Add another 90, you'd be straight down. Add another 90, this on where west would be 270 degrees. So that's a quick go over about bearings in general. Now let's do some examples and how to use the protractor to do this. So let's say you're asked to draw a diagram showing the bearing from A to B. From the points A to B is 062 degrees, so 62 degrees, 209 degrees, and 315 degrees. So what we start off with is the point. So let's answer A here. Let's say A was this point here, label it. So from A to B is 062 degrees. So firstly, you need to establish where true north is, and it's pretty much always going to be straight up and down your page. So you cannot see it on this video because I'm using a ruler on the screen, but I'm lining up a ruler. I'm lining it up with the end of the ruler, which should be square. I'm lining it up with the edge of the iPad screen, so I know that this line that I draw should be perfectly straight up and down. That's true north up there. Indicate it with an arrow, put an N there, that's true north. So our bearings that we get, like this 062 degrees, are in a clockwise direction from true north. So how am I going to determine where that direction is going to be? I need a protractor, so I'm going to grab one from photos. This is a protractor, and the way you use this, you can see this protractor goes to 180 degrees. It's 0 to 180 degrees. I need to manipulate this protractor so that the 0 degrees is lined up with 0 degrees true north. So I'm going to rotate it like this, put the center of the protractor on the point of A, because that's the origin of where this protractor, the direction is coming from. I'm just trying to line it up. It's very sensitive to the fingers, So if I can't do it straight away, sorry about that. I'm going to line up the center of the protractor with the point. 0 is lined up with true north because true north is 0 degrees. And so now it's lined up, I can determine where 062 degrees is by where it is on the protractor. So you go clockwise. That's 60 there. 62 is going to be 2 markings more clockwise than 60. So I have my point there. I've marked it on my page or my screen, for example, and now I can draw an arrow from A to the direction where B is laying. Oh, that's not very good. There we go. Still not very good. The difficulty of using a ruler and an Apple Pencil on an iPad screen just to get you videos to help you. So that is the direction B would be in. That is 062 degrees from true north. So that would be a diagram showing the bearing from A to B is 062 degrees. So let's try the next one. B is going to be 209 degrees, so more than 180. So we need to do a little bit of working out here because your protractor only goes up to 180 degrees. 209 is further than that, so I'd be laying my protractor and I'd have to be going clockwise and I'd have to go further than that. So you've got a couple of options here, but one of the options is to notice that 180 degrees, or 2 protractors, is going to make 360 degrees. So you can actually work out how much or what direction you'll need to go anti-clockwise by going 360 minus 209 degrees is going to be 151 degrees. But that's 151 degrees anti-clockwise. Okay, so if I was to do that, I need to set up my true north again. Set up where A is. A. True north. Directly up, that's 0, 0, 0 degrees. Oh, I'll need to move all this over this way. It's going to take up, it's going to go on the left hand side. So now I need my protractor again. But because we set up the maths before, we don't need to do this sort of thing. Put one protractor there and somehow grab another protractor and put it there to work out 209 degrees. What I could do is line it up this way and go anti-clockwise 151 degrees. This is annoying as heck. It's so sensitive to the finger. That's the best I can do, I think. It's going to be slightly off, but that's all I can do with this slippery setup. But we've got another problem here because you've got 180 lined up at the top. I was wanting to go 151 degrees that way, so how do I work out how to do that? Well, you can do the difference again. 180 minus 151 is 29. So that's telling you that if you were to go 151 degrees anti-clockwise, you would end up at 29. So my point on the protractor would be there, just before 30. So that gives me the direction from A that's pretty close. I'm not going to get worked up about that anymore. You just need to be able to see how to use the protractor. But you still need to refer back to this bearings wise, so in the clockwise direction. So that is up to 90 at that point, up to 180 at that point, and 180 plus 29 is going to be 209 degrees. 209 degrees. Okay, so that's another method of using the protractor when you go past 180 degrees, because unfortunately your tool only goes from 0 to 180 degrees. Are there any shortcuts or methods that I can use to work out how much further to go using the tool provided? And so lastly, 315 degrees. I think I could do it on the side here. C, 315 degrees. Let's put A to the right hand side. A is here. Indicate true north. Someone's got a loud car in front of my house. Indicate true north, which is 0, 0, 0 degrees. Now let's do some quick maths to work out how we're going to get 315 degrees when my tool only goes up to 180 degrees. Well, 360 is all the way around, so 360 minus 315 is 45 degrees. So that's telling me I'll need to go 45 degrees in the anti-clockwise direction. So you'll notice if I get my protractor again, and I line it up as I would like to, that's not going to work because it doesn't go far enough. It doesn't go past 180 degrees. So I have to turn it around this way and use some maths and logical thinking to work out how to use the protractor in this orientation. So I need to get it on A first, which has been very annoying to do. I should, I should be close enough. I want 45 degrees anti-clockwise. Unfortunately, because the protractor is on the left-hand side, it's not starting at 0, so I can't easily just count across. What I can do is work out 180, take 45 is, that comes to 135 degrees, and that tells me at 135 on the protractor is where 45 degrees anti-clockwise would be. So I put a dot on the protractor where I need it. I can go from the origin A to that dot. Nope, not right. Oh, still not right. Sorry about this. The Apple Pencil and the ruler are just not working very well. That'll have to do. So B would be in that direction there. So that is 90, 180, 270, 270 and 45. makes 315, I believe. 270 plus 45. Yes, it's 315. So that ring anti-clockwise there represents 315 degrees, which is what the bearing was. So that was a lot of trouble, but it's showing you graphically how to use the protractors. Hopefully that helps you out, and I'll see you in the next video.